Good morning and good afternoon. This is Michael Patton with Griswold Water Systems. I'd like to welcome everyone to our webinar, Understanding Legionella Risk Management in Cooling Towers and Compliance Solutions Utilizing Griswold Water Systems IntegraClean 2.0. We're going to cover today Legionella, the bacteria, and the disease Legionellosis and how it occurs. We'll talk about risk associated with Legionella in building water systems. We'll take a look at the compliance landscape in the United States. What do I do and who says so? And we'll also take a look at Griswold Water System products and how a comprehensive water management plan will help prevent disease and keep you in compliance that we'll be discussing. So as we go through today, please look at the GoToWebinar panel. There's a section marked questions. Please, if you have any questions that arise as we go through the webinar, type your question in and we'll organize those and answer them at the end. So what is Legionella? Well, it's a bacterium. It's not a virus, but it's an environmental aquatic bacterium. It's been around for quite a long time. It's also an opportunistic pathogen for both humans and other aquatic life forms. It thrives at temperatures from 70 degrees to 120 Fahrenheit. It's very happy at body temperature, which will play a key in the ecology of Legionella in humans. And if you want to disinfect, you have to get your water temperature up to about 170 degrees or have a half-hour kill rate at about 140 degrees Fahrenheit. Legionella will hide in biofilm, sludge layers, and dirt, and it finds protection naturally occurring amoeba and protozoa in the environment. It also enjoys dirty, rusty, corroded surfaces, which is why cooling waters, especially, a place that Legionella can harbor and survive quite well. Legionella pneumophila is a serogroup 1, is a type of bacteria that's responsible for about 90% of all Legionellosis cases. The serogroup was the one that was isolated in the 1976 outbreak in Philadelphia's Bellevue Stratford Hotel, where the Legionnaires were having their conference. And it's one of more than 60 species of the genus Legionella that's been discovered over the past several decades. And there's really only about 18 other species that cause infections, and rarely are these other 18 the cause of community outbreaks. So really, Legionella pneumophila serogroup 1 is the bacterium you should be testing and looking for. And what is Legionellosis, the disease that's caused by the bacteria? Well, Legionnaire's disease is a pneumonia-like lung infection with often accompanied by a dry, unproductive cough. You get severe headaches and malaise, and the symptoms onset about 10 to 14 days after exposure. We'll go through what that exposure process is. That's often accompanied by body aches and high fever. Another part of Legionellosis is called Pontiac fever, and it's a flu-like reaction to exposure to amplified Legionella bacteria, generally in a much shorter time, 24 to 72 hours after exposure. Generally, it's not fatal, but cases of Pontiac fever have been known to transmit over to Legionnaire's disease. So how do individuals get sick? Well, all experts agree that a person needs to deeply inhale the mist or aerosols that contain the amplified Legionella bacteria. Most humans can fight it off, and infection rates generally fall in about 5% or so of the general population. Mortality for those with infection, the Legionnaire's disease infection, is about 10 to 20%, and it can be higher in hospital healthcare settings. Some risk factors for persons to make them more susceptible would be smokers, older persons, age 65 and older, those that are health challenged or undergoing transplant or chemotherapy, and also diabetics. All of these people have elevated risk for acquiring the disease once they have breathed in the bacteria. So the path to Legionnaire's disease is very well understood. Legionella exists in the environment. It can be found in many sources. It's also found in treated drinking water. And we'll talk about what the EPA has to say about that in a little bit. But the real key to Legionnaire's disease is when you alter the ambient temperature of the water, heating it for domestic hot water purposes or using it for cooling water, it plays perfectly into the ecology of Legionella. And we saw that with the temperatures. Also, a mature biofilm is required for the amplifying vectors of amoeba and protozoa to survive in the aquatic system. Now, this could be in nature or in the man-made cooling water or domestic water. The protozoa feed on the biofilm. If there's no biofilm present, then there's no support for the amoeba populations. And this will be really important because amplification is the cause of Legionnaire's disease. Without a biofilm, you can't have the amplification that can be dangerous to humans. So in that water temperature between 68 and 120 degrees, Legionella hijack the amoeba, and the Legionella reproduce rapidly, and they become more virile and more infective. So regardless of the temperature, you need to keep in mind the mature biofilm is required to support amoeba populations, which are the amplifying vector for Legionella bacteria. So this takeover is rapid, and it's very quick, and these highly Legionella bacteria get released into the water, and then the aerosol is produced. So that aerosol from the cooling tower or the shower, the domestic hot water system, from spas, from decorative water features and fountains, anytime you have that aerosol that's infected with these amplified Legionella, that's how the humans will be exposed. And infection in humans requires a deep inhalation of the aerosol down into the alveolar region of the lungs. This is where the blood and oxygen exchange takes place. But once there, the Legionella bacteria find what are called macrophages in the lung. And the macrophages really resemble amoeba in their natural aquatic environment. Macrophages are basically the cleanup artists inside our lungs. They're the one who are taking out the dirt, particulate, bacteria, viruses, all the stuff that we breathe in that the body wants to expel. And as the Legionella get absorbed into those macrophages, disease can occur. So let's look at this again a little bit more in a little bit more detail. We start with low counts of Legionella species coming into a cooling tower, and you can see that on this particular sphere of disease risk, that box for the low counts of Legionella species is half in and half out, meaning, yeah, just because you have Legionella doesn't necessarily mean that you're going to have disease from that particular piece of equipment. However, if the system is not controlled well and a mature biofilm is produced, that feeds the amoeba population, and then the Legionella find a home and amplify inside these amoeba and release that virulent strain of Legionella into the water. Now, at about the 7 o'clock position, these red boxes indicate what happens once the aerosol has been produced and you are leaving the equipment. So you're leaving the cooling tower, you're leaving the spa or the decorative water feature. There is no longer an ability to control what's happening in the water anymore, because now you're transmitting it to humans, to an at-risk individual. And then if those droplets are deeply inhaled, you can develop patients with Legionnaire's disease. So the point at which chemicals must stop the cycle, but often don't, is here. This is trying to catch the amplified bacteria before it is released from the equipment. And that's the last opportunity to stop this cycle. A better idea would be to prevent disease where it's best applied, but is also most difficult, which is eliminating or preventing the development of mature biofilm. If so, in the case of the last gasp, you have to have enough disinfectant in the system to catch an amplifying event. Catching an amplifying event is a rare occurrence, and it doesn't happen very often. And the reason is that the biofilm harbor bacteria, including Legionella. They shelter microbes from chemical attack, from other aquatic attack in the system. And it's a tough polysaccharide slime that really prevents even high chlorine doses from eradicating the biofilm. And as the system progresses, new pioneer bacteria go out from the mature biofilm and establish new colonies elsewhere in the system. So mature biofilm is a self-regenerating aspect in cooling water. So with that understanding, let's take a break from the science side and let's talk a little bit more about compliance. And there is compliance confusion. There's no question about it. People are hearing lots of things in news and media reports, developments in New York City and New York State. Well, the compliance really depends on where you are located and even what sector of building management you are in. So we're going to look at regulatory compliance on the federal, state, and local level, city or county. And we'll talk about these various agencies that are listed here. We'll also talk about voluntary compliance in accepted industry standards with ASHRAE Standard 188, ASHE's guidance, the Association of Water Technologists, and CTI. And we'll talk about risk management evaluations. What standard of care do I need to follow to avoid or mitigate legal entanglements? Now, the major disclaimer here is that we are not providing legal advice. If you have a building management program and you want specific advice, legal advice as to what your exposure may be, you'll have to seek it elsewhere. I'm just going to show you today where you what guidance you need to look at based on either your location or your building sector. So let's talk about federal agencies and regulations or guidance that's been issued that would apply to everyone in the United States. Well, first there's OSHA, the Occupational Safety and Health Administration. They have guidance, but it's limited to defining what steps to take after a worker becomes infected. And that may even be before you have identified what the source is, because as we just looked at, it could be something that comes from the home, not necessarily the workplace. So the OSHA guidance gives you steps on investigation, mitigation, and ongoing monitoring once that case has been proven to be caused by your facility. The Veterans Administration, the Hospital Administration, has issued many policies for prevention of Legionellosis, the most recent in 2014. That's VHA Directive 1061. This describes what to do primarily for domestic hot water and domestic water situations. A lot of people suggest maybe that the EPA has a role to play here, and it does. The EPA delegating to the various states regulates the maximum contamination level for Legionella species in potable water as 0. And it's the same as with cysts like Giardia and other viruses. Now that means leaving the plant. That does not necessarily mean entering your premise. The EPA's guidance that if a building water system, otherwise known as premise plumbing in EPA speak, if it tests positive, then you have to act with the local health department. What the EPA doesn't say is that you are going to receive water from your local utility that is free from Legionella at the meter. It just says that there will be no Legionella leaving the plant. More responsible utilities do more distribution system testing to look for Legionella and other pathogens, and then adjust their disinfection or do flushings. But that's spotty and not universal and not required by the EPA. So to help building owners, there's a non-regulatory document that synthesizes a lot of the guidance that's available in the public, and it's EPA 815D16, issued just earlier this year in its final form. It had been in draft since 2015. We'll give you links to all of these resources later in the broadcast. The CDC, the Centers for Disease Control and Prevention, also has guidance but no regulations. It has an extensively developed program for diagnosing human disease that's done in cooperation with the National Institute of Health. For prevention practices, and that's really what we're trying to talk about here today, it references ASHRAE Standard 188 and ASHRAE Guideline 12-2000. And it has gone to the extraordinary step of developing a companion guide for ASHRAE Standard 188 that's known as the CDC Legionella Toolkit. We'll talk a little bit more about that as we go along. So, capping federal regulatory compliance, there are no federal regulations regarding operational Legionellosis prevention practices. And that asterisk is just for awareness that they can have potential for OSHA fines for disregarding corrective actions and monitoring as defined in what we call Chapter 7 of OSHA. However, taken together, the documents from these various federal agencies can offer an outline for a standard of care. But again, there is no one individual agency requiring compliance. So now we'll move on to the states. And if you thought that the federal government was going to be confusing, well, hold on to your hats, because state guidance is also all over the map, so to speak. The Wisconsin Protocol was developed in 1987 by the Wisconsin Department of Health as a disinfection procedure for cooling towers. It's no longer distributed, but it's still widely applied as being a first, initial, and fairly decent standard for disinfection protocols. In 2004, in the state of California, they issued guidelines for power plant cooling tower testing for Legionella, and those still exist. In South Dakota in 2005, they issued a guideline for ornamental water features. That guidance is still in effect. And then in the healthcare sector, there's specific guidelines that have been issued in Maryland, Texas, New York, New Jersey, Louisiana, Nevada, and that should be Utah. I think it is, but looks like we lost the T. So in each of those particular states for the healthcare sector, they have developed protocols and guidelines, in some cases regulations, for healthcare organizations to follow. And these are a mix of primarily potable water protection and sometimes mechanical equipment such as cooling towers. So if you live in those states, you need to, and you're working within the healthcare sector, you need to understand what that guidance and regulatory action is in each of the states. In 2015, New York State issued regulations under the authority granted to the New York State Department of Health in the code relating to healthcare potable water regulations. So this was a sweeping regulatory action that required no new legislation, but worked off of existing code language regarding the healthcare potable water regulations that were already in effect. So it became an expansion into the cooling tower sector, not necessarily the potable water sector in these buildings, but for cooling towers, that now requires owners and operators to register their cooling towers, to do periodic Legionella testing, file their water treatment plans with the state for any cooling tower that exists within the state. It's really a quite sweeping set of new regulations. So these are must pay attention to because they are regulations in New York State. So other than the state of New York and California, in the power sector. There's no regulations for the private sector cooling towers, with the exceptions of the healthcare sector and electrical power industry in California. So again, there's no one answer universally that says that you must do certain things or that you must report certain things. It is a little bit more of a hodgepodge. Under local regulatory guidance, there's some interesting things. Allegheny County, Pennsylvania, has long had an interest in healthcare setting covering only potable water. So for over 15 or 20 years, they've had guidelines, again, not regulations, but guidelines issued by the Allegheny County Health Department covering what to do for potable water in the healthcare sector. Kind of interestingly, in 2005, Garland, Texas passed an ordinance which requires the testing of cooling towers for Legionella pneumophila in multifamily dwellings. That's the only, besides New York City, which we're going to get to, that's the only other city locale that I was able to locate that said that testing or paying attention to cooling towers for Legionella is required. And then New York City. In 2015, they passed an ordinance, and in 2016, subsequent regulations which requires the registration of all cooling towers, like New York, filing a water treatment plan and quarterly Legionella testing. However, the New York regulations went much further, requiring weekly biomonitoring, total bacteria counts, daily logging of system conditions, including conductivity and other indicators, twice yearly cleaning, and defines very specifically a paper trail and audit procedures for the same. They are hiring inspectors who are going out and, as you would see with health inspections, SNAP inspections like you would get at a restaurant, they're beginning to do this into private businesses around the 5 boroughs. One of the problems or one of the hurdles associated with these regulations is that the only disinfectant that's pre-approved within these regulations is for halogen, chlorine, or bromine products. All other chemicals and methods require a waiver, and this includes a host of different non-oxidizing biocides that have proven to be relatively effective at maintaining biological populations and some at keeping Legionella bacteria itself under control. So that's a brief look at local and state guidelines. Let's talk now about what I call accepted industry guidelines and standards. Who has what that can be universally applied in the absence of any other regulation? Well, ASHRAE's long been involved in the information transfer about Legionella and Legionellosis and disease. And in year 2000 issued Guideline 12, minimizing the risk of Legionellosis associated with building water systems. This guideline is currently under update and review within the ASHRAE technical committees, and expecting an update within the next several months, multiple months maybe. They also have issued in 2015 Standard 188, which is titled Legionellosis Risk Management for Building Water Systems. This is now a continuous maintenance standard, meaning that as new things come up or as new science is available, the standard can be modified quickly as opposed to a 4 or 5 year cycle. This Standard 188 is the standard that Griswold Water Systems prefers to look at because it is universal in looking at building water systems as well as other aerosolizing devices such as cooling towers, and it gives advice as to how to set up a risk management plan. And this is going to be really important as far as that high standard of care. CTI has 148, which is a guideline for best practices for control of Legionella. That's currently under update and review as well. In 2003, AWT issued their Legionella statement, and ASHE and the Joint Commission in 2001 establish an environment of care that does include maintaining your cooling towers appropriately to prevent association of, or proliferation of not only Legionella but other pathogens found in cooling water. So all industry guidelines and standards are currently voluntary, except for New York City and New York State, where limited portions of ASHRAE 188 are referenced. The ASHI-JACO guidelines are part of their accreditation process for the Joint Commission. So those basically have to be paid attention to if you want to maintain your certification with those organizations. One thing that's interesting to note is that in many standards that are issued by ASHRAE and other building code type standards usually take a minimum of 5 years or more to be adopted by local codes, generally meaning state codes, sometimes local building codes, including something like New York City. However, this can change very quickly by local ordinances, as we saw in New York City and also in Garland, Texas, or state regulatory action. These can be very quick, very swift, causing industry whiplash. So you need to be on guard and monitoring your local governments and state governments for any type of actions along these lines in order to protect yourself and your facilities. So, in the nutshell, here's compliance to keep you out of hot water, so to speak. In the healthcare sector, look at the Joint Commission Environment of Care in the ASHI guidelines, and also contained within ASHRAE Standard 188, there's Annex A, which is specifically applicable to the healthcare environment. It matches quite well with the other components within the federal government, Centers for Medicaid Services, Medicare and Medicaid Services, and it blends very well with existing hospital and healthcare sector infection control processes. Any other building in the United States or even internationally, you'd probably want to look at ASHRAE Standard 188 as long as you're not in the power sector. If you are in the petrochemical or heavy industry or power, looking at CTI 148 is probably going to be your best guidance. And then, as stated previously, you see specific regulations published for New York and New York City, and also for the other states that we've mentioned in the healthcare sector. So here's kind of a recap too as to what to do if an occupant of your facility is diagnosed with Legionnaire's disease. The first step of contact will be with your local health department, not the CDC. If you call the CDC, they'll refer you to your local health department. The local health department may or may not have guidance and instruction for you. If they do not have guidance and instruction, then you want to look to OSHA guidance regarding notification, sampling, etc. If it's been confirmed that Legionellosis occurred from your facility, you need to sample and test for Legionella extensively. Do not assume the source as a cooling tower or something else. It could be in the potable water, and those sources should not be ignored. Anything from ornamental fountains to medical misting devices, etc., all need to be sampled, and you need to do that for your own protection. And again, being aware of OSHA guidance on ongoing surveillance and monitoring is also important, and document all actions taken. This will keep you out of hot water, and this will show that you're taking reasonable steps to mitigate any outbreak within your facility. So with that compliance review, let's talk a little bit about how Griswold Water Systems, IntegraClean, and Wave can keep you both in compliance and give you the best protection possible against Legionnaire's disease. Our flagship product is called IntegraClean. And as a quick review, IntegraClean combines Wave with Clean Sweep, which is a revolutionary new basin sweeping product. It's the most advanced water treatment, solids control, and energy savings product available from any manufacturer. The Clean Sweep is a novel way of keeping your basin clean, keeping it free from sludge that the Legionella likes to hide in. It at very low pressure, it gently moves settled solids along the basin floor to a point where it's basically vacuumed up through the exit header back out to the separator, and all the settled solids and heavy solids are kept away from your chiller or your heat exchanger. Having a clean basin is chiller protection only with Clean Sweep. Very efficient solids removal, more so than the existing high pressure turbulence creating basin sweeping that's been accepted in the industry for decades. It's easily retrofitted into any tower design, and it prevents solids from collecting at your heat exchanger. And those nozzles that stir up the settled solids, all that does is send them right back into the chiller, entrained in the water. So when installed with part of IntegraClean, CleanSweep manages these solids and keeps the basin cleaner, but also doesn't give you an energy penalty of solids at your heat exchanger. Coupled with CleanSweep is Wave. Wave water treatment utilizes electrodynamic fields to prevent scale and also to control biological growth. And the water characteristics that the Wave operates in is very good against corrosion control. So let's just look at some issues here with our equipment and how that lines up with disease prevention. We've talked a lot about biofilm as being a source of amplification. So if you have no biofilm, getting amplification out of that system is going to be very difficult. And if you have no amplification, that means disease prevention. And where does the biofilm grow in cooling water? Well, it grows in low flow areas, dead legs, stagnant piping, and in sludge and cooling towers. So the Griswold water system remedy is to use IntegraClean 2.0 with basin sweeping that protects your heat exchanger efficiency and provides basin cleanliness. Rotating chiller room equipment so you don't have stagnant water is very important. As far as dead legs and other stagnant piping, make sure you're purging basin equalizers or slightly unbalance the cooling tower basins to push water through so that that water is treated continuously. Often you can cross-connect large supply and return headers to prevent shoulder season stagnation at low loads and low flows. So let's look at some data as to kind of proof in the pudding as far as what Griswold water systems technology can provide. This is from a set of field studies with pulse power water treatment that was presented at ASHRAE a year ago. What this did, it went back and looked at a set of papers looking at the highest planktonic counts, sessile, which would be the biofilm, corrosion, and any deposition. So what I'd like you to look at here is a couple of papers going back into 2008 all the way up to 2015, where a qualitative examination of biofilm, the sessile bacteria, was absent by touch in some earlier studies. Later in 2014, 2015, those biofilms were enumerated to be very, very low, under 150 colony forming units per square centimeter. Now, if you look above, as far as the metric is concerned, the common metric is 10 to the 5th per centimeter squared, or absent by touch. In the cases we're seeing here with pulse power water treatment and Wave, very, very good control of the biofilm, as well as very, very good control of the what we call planktonic or free-floating bacteria. So how does all this work to help develop that high standard of care we were talking about earlier? Well, as I stated, Griswold water systems believes that standard 188 is a very good standard to follow for creating a plan to prevent legionellosis. And it should apply to the entire building, not just to the cooling water. But there is very good guidance as far as how to do that for cooling water as well. Understand that there is as many paths to compliance within the standard as there are buildings. You are building this standard shows you how to build a customized plan for your facility. And except in New York City and New York State, compliance is voluntary, but it does illustrate an intent to develop a high standard of care. And what does Griswold Water Systems do? Well, we will develop that customized water management plan for our customers. We'll talk about the maintenance practices and define the maintenance practices to be utilized for cooling water. We'll talk about the operational practices to avoid stagnant water, as we discussed. Make sure that the cooling tower is clean, providing centrifugal separation and biological efficacy in the control strategy. And that can be done with visual inspection, periodic plating, lab plating, 9215B total bacteria count testing. And this does not necessarily mean testing for Legionella bacteria. And then confirming the absence of biofilm in a wave-treated tower is very easy to do, and we continue to develop methods and materials to make that an ongoing and provable, not just a qualitative aspect, as you could see from those studies referenced earlier. So let's review again a little bit as to why our confidence of this is so high. So this re-showing you now this path to Legionnaire's disease and that sphere of disease risk. And we talked about the point at which chemicals must stop the cycle but often don't or can't. Keeping in mind, again, that once the amplified bacteria leave the equipment, the opportunity to act against it has now disappeared. So those three red boxes are very important because that means that once the Legionella are out of the equipment, there's nothing you can do. So let's look at the new paradigm with Griswold Water Systems IntegraClean equipment. Again, we're looking at the same box for low counts of Legionella species entering the water from the utility system or from the air. That is in or out. That doesn't mean that you're going to or not going to have disease, as well as low total bacteria counts. That doesn't necessarily mean you won't have disease, but once you look at the lack of biofilm to support the amoeba and the amplifiers of Legionella, the reduction of amoeba populations, the dangerous amplification then is not possible. So there's no way for infectious bacteria to even get out of the system. That's why these boxes are labeled green. It's very, very important to understand that the Griswold Water Systems Wave and IntegraClean handle the Legionella risk inside the equipment. It doesn't depend upon the vagaries of what may happen once that amplified bacteria escapes the cooling tower. To illustrate this and develop it a little bit further, at Griswold Water Systems, we've authored a high standard of care utilizing IntegraClean 2.0, and it's a comprehensive and detailed outline how to deal with Legionella in cooling water utilizing Griswold Water Systems equipment. And it's complimentary with your attendance at this webinar. We'll give you details as to how to get that in just a minute. So I have a listing here of these helpful resources. If you want to take a photo of a screenshot, you feel free to do that at this time. Also, we'll have these available to you, these hot links on a Word document that we can give to you if you wish to contact us in the future. So these resources cover OSHA, CTI, AWT's 2003 statement, Joint Commission information. You can view for free the ASHRAE standard online at that following link. There's also Guideline 12-2000 that is available from legionella.org, as well as some information on the Joint Commission Environmental Care Standard. And also down here at the end is the CDC Legionella Water Management Plan Toolkit that is a handy how to do it for ASHRAE Standard 188. If you're in New York or New York City, these are links to those regulations. Hopefully, if you own a facility and you are in New York or New York City, you already know about this information, but again, we'll provide those to anybody who needs them. So what we've covered today so far is Legionella, legionellosis, and how it occurs, the risks associated with Legionella in building water systems, the complicated compliance landscape in the United States, and how Griswold water system products and a comprehensive water management plan help prevent disease. So at this point in time, we'll take some questions, and as we're assembling those, if you would like to have a certificate attendance for your ongoing PDH credits, please just email Kat Templeton at the email address shown there, include your name and title, and then we can get that out to you for your PDH. And for any water treatment professional guests who are on board, if you want to learn about joining the Griswold Water System Certified Service Provider Network, you can get to Mike Jakubowski at that email address down below. So we'll, Kat, if you're available, can you open it up and we'll start looking at questions?
I am. And thank you very much, Michael. That was very, very interesting and helpful. We've already got a few comments and a few requests, which we're taking care of here. One question, someone has asked if we can get a PDF of the presentation itself. And the answer to that is yes. Ask me for one by sending me an email, and we'll be happy to make that to you. Even more importantly, we are recording this webinar, and it will be available on our YouTube site as soon as we make that conversion. At that point, I will send all of the attendees a link to that program. You will also be receiving from us a white paper, which is a very helpful document on a high standard of care for the prevention of Legionella. So, what questions do we have?
So what you do is, if you have a question, the box, type your question in the questions box on the GoToWebinar control panel that's on the left side of your screen.
Okay. We do have a question here. It's about makeup water quality and highly corrosive water or with a lot of hardness or silica. I'm guessing that question is how well Griswold Water Systems handles that kind of water with IntegraClean.
Yeah, that would probably be more of a general water treatment question rather than one about compliance issues or effectiveness against Legionella. Our process, the wave electrodynamic fields, is still subject to certain limitations of makeup waters, including cycled up chlorides and cycled up silica, that we have limits that we have to pay attention to prevent deposition and excessive corrosion in the system. The hardness aspect, depending upon the concentration of calcium hardness and total hardness and alkalinity, we can actually evaluate that for any prospect and help you identify the best solutions for wave or IntegraClean in those applications. So hardness, high hardness waters does not prevent a barrier to utilizing wave and IntegraClean.
Thank you, Michael. Are there studies that indicate that Legionella counts are found in the bulk water, not only in the biofilm?
Yes, there are. There's multitude of studies and surveys which show that the amplified Legionella escaping into the water is how the transmission to humans occurs. So finding Legionella in the bacteria or in the biofilm is not very difficult. It's easy to enumerate those in a biofilm, just as it is fairly easy to enumerate what we call free floating or planktonic Legionella. The planktonic Legionella are the ones that can become dangerous to humans if they're amplified. Very often there are low counts of Legionella bacteria of any number of species that you wouldn't necessarily have to be concerned about. It's the amplified bacteria that rapidly increase that free-floating bacteria, Legionella bacteria population that you need to be concerned about. Most guidance that you'll see including New York State, New York City, looks to try to maintain cooling water general populations below 100 CFU per milliliter um, as a good place to be. And then above that, on an order of magnitude, if you get to 1,000, then you get into a disinfection protocol. If you're at 100, you may want to look and maintain or double check your water treatment program to make sure it's delivering the right um, the right dosing, and that your operational practices are consistent with keeping those populations low and keeping chemical residuals recirculating. With Griswold water systems, we don't have chemical residuals. However, recirculation protocols are very important.
Okay, thank you. And Larry McLaughlin would like to know whether or not we recommend any biocides be fed in conjunction with the IntegraClean system. And he would also like to know if well, let's answer that question first. Is there do we recommend biocides in addition to Griswold water systems?
There is no need to feed in biocides when you're utilizing Wave or IntegraClean. In certain jurisdictions, such as New York City, we are forced by regulation to uh, to feed in a a biocide, but that's because we don't want to violate the existing regulations. We are working with the state, with the city of New York, to try to demonstrate to them that you can not have to feed this in. But again, they're swamped right now with tons of waiver requests from anybody who wants to use any other non-oxidizing biocide in the system. So that process will take a little bit longer. But Larry, to answer your question, there is no need to feed um, any biocide in when you're operating a Wave water treatment or IntegraClean system.
Okay, thank you. A question that's related to that. Is there a test we could conduct to confirm or refute the presence of biofilm in the system besides biocoupons? And along with that, specifically, have we done testing for Legionella as well as TBC in an IntegraClean treated system?
Well, those are two very good and very specific questions. The answer to both is yes. Well, not the answer to the first one is utilizing biocoupons, and we're developing our own process and basic standard for that, absent any guidance in either the literature or ASTM or standard methods. Does is totally silent on testing, on monitoring for biofilm in building water systems, whether it be potable or cooling water. So we're actively engaged in setting that up. We're actively engaged in doing the kind of testing that you're asking about in the question, and there will be a series of papers at various venues upcoming over the next year or so that will show the success of these efforts on our part. Other than bio coupons, um, there are some other electronic means which involve hot wire tests and biofilm on hot wire and what that does as far as the uh, presence or absence of biofilm. Those have proven to be very expensive. They have uh, a fairly decent but not completely foolproof track record. It appears at this point in time that biocoupons are going to be the best way to try to understand what your biofilm is in a given system.
Okay, thank you very much. Um, Have we, whoops, sorry, that was someone asking us for a thank you. This is a question more about the overall system, but that's I think it's a good one. Um, we have a guest who would like to know if we have industrial experience, high scale prototype for cooling towers in the petrochemical industry.
Um, the heavy industry, large uh, industrial cooling water systems, it has not necessarily been a market for us. Those um, the petrochemical power, they rely heavily on the use of high dosages of primarily chlorine and other halogens. Um, it just has not proven to be a market for us. I don't believe we even have any white papers on that um, in our possession. So that's not necessarily a market for us. The Griswold Water Systems market for water treatment is generally speaking, office buildings, commercial hospitals, educational setting, both college, universities, K through 12, um, and owner occupied buildings. Industrial buildings are perfectly fine. Food processing is perfectly fine. But when you get into petrochemical and power, it's not an area where we've had a lot of penetration into.
Okay, thank you very much. We seem to be at the end of our questions. Have I missed anything? If so, type your question in now.
Well, while we're waiting for the final questions, if they do appear, I want to thank you all for lending your time. We tried to keep this to be about 45 minutes, and I think we did pretty well on that. So thank you very much for your time, and enjoy the rest of your day and your week. Kat, have you found any other questions?
Okay, we're getting a number of people who have thanked you, Michael, for an excellent production. And we do have one more question. Can the system, not the filtration piece, be used in a domestic hot water system? That's a good question.
Boy, it's an excellent question. The This is not necessarily a market that Griswold is pursuing currently. However, um, the technology has been utilized in potable hot water in other locations in Europe and other places. Um, that's a very prickly question, and I could tell you that there has been demonstrated success, but it's not a market currently that Griswold Water Systems is pursuing.
All right, thank you very much. A couple more thank yous. I think that seems to be it in terms of questions. If you do think of a question, you have my email. Please do not hesitate to ask me any kind of a question you wish, and I will be happy to either answer or send it along to someone else. One more late question. Can you comment about UV light treatments?
UV has been shown to be a very good disinfectant for bacteria of all types. Um, it's utilized in some potable water treatments at water treatment plants before it goes into distribution systems. UV can be very well done, but the cleanliness of the water, the clarity of the water, really can be a limitation to UV being acceptably utilized in cooling water systems. The but yeah, UV is a very good disinfectant. You usually see that on smaller volume systems, and sometimes high purity water, etc., where you've got maybe a 2 inch or 3 inch pipe, and they're treating UV with a side stream. So it has definitely proven effective as a biocidal application, sometimes used in conjunction with chemicals, sometimes alone. So yes, it definitely would be um, if you have certain concerns or in the healthcare setting, it might be something you want to look at as far as incoming potable water is concerned.
All right. Any more questions? All right. Well, Michael, thank you very much. And to all of our guests, we thank you very much for your attention. We wish you a very good holiday. I think we're out. Okay.